So we are going to continue with our definitions of trigonometric functions. We talked about the definition of tan of an angle. So in our unit circle, we took the unit circle, right? And unit circle is just a circle with radius 1, right? And we have this making an angle theta or x, right? And we saw that the x coordinate is cos and the y coordinate was sine, right? So uh, we defined the x coordinate ON, which is the x coordinate, to be cos of an angle, and PN, which is the y coordinate, to be the sine of the angle. We also looked at the definition of tan theta. So the definition of tan theta was y by x, right? Where, but we had to exclude the values where x was 0, right? And we saw x was 0 at, we saw that x is equal to 0 at which values? Pi by 2, 3 pi by 2, and so on. And in the negative side, we had minus pi by 2, minus 3 pi by 2, right? And so a general formula for this was 2n plus 1 times pi by 2, where n is a natural number, right? So the definition of tan theta will be tan theta is equal to y by x, provided x theta cannot be a few angles, right? So theta belongs to the set of real numbers. All other values of theta are possible. Only these values of theta are not possible, right? So from the set of real numbers, we remove the set of 2n plus 1 pi by 2. Okay. Okay. So given n is a natural number, right? Here n belongs to natural number. So that is the definition for tan theta. Okay, so theta belongs to the set of real numbers minus 2n plus 1 pi by 2, where n are the set of natural numbers. Okay. Now we need the other definitions. So we have sine, cos, tan. We need secant, cosecant, and cot. Okay. Secant will be similar to secant is 1 by cosine. Okay, so cos is x, so you'll get 1 by x, right? So what about the range of values for which, sorry, the values of theta for which we can use? Again, where x is 0, secant is not defined, and x is 0, we saw at these values, right? So theta belongs to the set of real numbers minus 2n plus 1 times pi by 2, where n is a natural. Okay. What about cosec and cot? Cosec is defined as 1 by sine, right? So, but sine theta is nothing but y. We saw that sine theta is y. And this will be defined for what values? So we can define cosec theta as 1 by y. And this will be defined for what values of theta? This will be defined for theta belonging to set of real numbers minus set where y is 0. Now, where will y be 0? Well, this, if you look at this ray, right? So, this coordinate is a y coordinate, this coordinate is the x coordinate. And we saw that when this ray comes here, the x coordinate will be 0, right? So when this ray comes here, the x coordinate will be 0. Similarly, when it goes down, also the x coordinate will be 0. Then where is the y coordinate 0? The y coordinate is 0 when it will be here, right? The x coordinate is 1 or the y coordinate is 0. And similarly here, x coordinate is -1 and y coordinate is 0, right? So either 0 or pi or 2 pi and 3 pi. Similarly, in the negative direction, 0, -pi, -2 pi, and so on, right? So uh, y will be 0 for what values? Y is equal to 0 for 0, pi, 2 pi, 3 pi, so on. And negative directions, -pi, -2. Okay. So for n pi, n belonging to n, we will have this y going to 0, right? So this can be written as n pi. So from the set of real numbers, we remove n pi, and that will give us the values of theta for which cosec theta is defined. And similarly, cot theta is just x by y for all theta belonging to set of real numbers minus where y is 0, right? Where is y 0? Again, it's the same points. These points are nothing but n pi. So you'll get r minus n pi given n belongs to let's say. So that will be definition of cot theta. Okay. So we have defined sine, cos, tan, secant, cosecant, and cot. So we have defined all these different angles in terms of our new definition, in terms of our unit circle definition. Let's move ahead and look at the values of some sine angles and some cosine angles. Yeah, need to find the sign of negative angles. So we're looking at negative angles. Right. So if sine theta is like this, we have to find the following. Sine of minus theta, cos of minus theta, and the remaining angles. Okay, tan, cosec, cot, etc. Now, if sine theta is like this, the ray is like this, how will minus theta look like? How will the angle minus theta look like? Minus theta will be just if you draw this ray towards this side in the positive direction, that will give you theta. In the clockwise direction, that will give you minus theta, right? So this angle, you have to draw the ray. So you have to draw the ray such that this angle will be theta, right? In this direction. So this will give you minus theta. If this is theta, this will give you minus theta, right? And then this is your n, this is your p dash, right? And where these angles are 90 degrees, right? Okay, now what can we tell about sine of minus theta? Sine of minus theta will be nothing but minus theta is this ray, so the y coordinate is this point, right? So which is nothing but this length. But how much is this length? P dash n. If we related it to this, here we know this is sine theta, this is cos theta, right? Are these similar to this? Are they different? What do you think? They will be exactly the same. Okay. This triangle is congruent to this triangle. Why? Think about it. Why are these two triangles congruent? One of the angles is the same. Okay. Further. Well, this side is common, right? And what about the third angle? This angle is 90 degrees, isn't it? So this angle, this side, and this angle, third angle. So using ASA, right? Using ASA, you can prove that PNO, triangle PNO is congruent to triangle P dash N, right? So if these two triangles are congruent, now you have PN length equal to P dash N, right? So length PN is equal to length P dash N, right? And P dash N, PN we know is sine theta, right? P dash N is this length, but in the negative direction, right? So what will be sine of minus theta? It will be negative of sine theta. Okay, it will be negative of Pn, which is negative of sine. Okay. What about cosine of minus theta? Cosine is the x coordinate, which is this, right? And the x coordinate is the same for this point as well as this point, right? The x coordinate is the same. So cosine of minus theta will be just same as cos theta. Now, once we have sine and cos, we'll be able to do all the other angles. Okay, we'll be able to do tan. What is tan of minus theta? Tan of minus theta is just sine of minus theta by cos of minus theta, which is sine of minus theta basically is minus sine theta, cos of minus theta is cos theta, right? Which is minus of sine theta upon cos theta is just tan theta, right? So tan of minus theta is minus of tan theta. Similarly, secant of minus theta will be 1 by cos of minus theta, and cos of minus theta is cos theta, right? So which is 1 by cos theta, which is just secant. Similarly, cosecant minus theta you can prove will be minus cosec theta, and cot of minus theta you can prove is minus cot theta. Okay, you can prove this in the same methods that we have done here. Okay, so finally we have simulation here. So basically this is our unit circle and this is our array which I can rotate around. Okay, and here it shows you the angle. Okay, so let's keep it at 0 angle, and I can have some you can do this on your own. You can go to Trick Tour in PHET and you'll get the simulation. Okay, so first we are going to see if you look at this value here, we are looking at the cos value here, and the cos is nothing but this blue arrow here, right? So you see that when we keep it at the extremum, the blue value is maximum and its value is 1. And we come from 0 degree, we come to 60 degree, the value is decreasing, right? It's further decreasing, it becomes 0, right? And then once you cross over into the second quadrant, it starts to get negative, right? It becomes negative and goes further down, and it reaches an extremum point here where its value is -1, right? And then it further decreases, becomes lower negative value, comes to 0, and then and slowly it increases and becomes 1. So that is 360. So let's correspond this let's look at sine. Okay, so sine, if you're looking at sine of 0 is sine is the y coordinate, right? At 0, sine 0 is 0, right? And slowly, once it increases, the value of sine also you see the height is increasing. As it reaches 90 degree, this green arrow will become 1 at the maximum. Then in the second quadrant, slowly it is decreasing, it goes to 0, right? And in the third quadrant, the value slowly will be negative value. Now it's in the downward direction. So negative is it's slowly increasing, right? in the negative direction, the value is increasing, right? So it's becoming, it reaches an extremum here, which is -1, correct? And then again it goes and decreases and becomes 0. Okay, so sine 360 will be same as sine 0, right? So after 0, you will see that again the same thing repeats, right? The same thing that happens from, if you start from 0 and go to 360, the same thing will repeat from 360 to 720, right? Exactly the same thing. So that's a special property of the graph of sine. Okay. So basically, if you were in class, we would have made you sit and plot the graph for sine and cos. But here we can't do that. So that's why I'm showing you this. So corresponding to each value of the x-axis, the x-axis is divided into radian measures. Okay, this is 0, this will be pi, this will be 2 pi. Okay. Now, as I slowly, I have to take some special values, specific values. So, say first I want to find the value of say sine 30 degree. Okay. So how can I measure it on the graph? Well, what I could do is I could, take in a protractor 30 degree, right? And draw a line here on the unit circle. And whatever this height is there, that will give me the corresponding y coordinate. X coordinate for that, x coordinate for the, this will be pi by 3. Sorry, pi by 6, which is 30 degree. Okay. And then you move ahead, you go to 60 degree. So you look at 60 degree point here and you look at its height on the graph, and then you kind of extend this to this point. That will give you sine of 60 degree. Okay. And then further you go ahead like that. You say sine 90 degree. 90 degree is just this line, right? And the vertical value is just 1 here. So sine of 90 degree, which is pi by 2, will be 1. Then 120 degree, which is 2 pi by 3. Okay. So 2 pi by 3, you take the value and see that you will get, you extend this, and then 150 degree, which is 5 pi by 6. Okay, again you extend this, you will get here, and then you go down, and then it becomes negative, right? It goes to -1 here at 2 pi by 3, and then at 2 pi it will go to 0. Okay, so this is the sine graph from 0 to 2 pi. It goes from here up to here. Okay. And further it will move, the same graph will repeat. Okay, so if you see this kind of graph is called a periodic graph. What is a periodic graph? Where the same graph repeats after some interval of time. Okay, and the minimum time interval after which it repeats, that is called the period of the function. So what will be the period of this sine? Can you tell what will be the period of the sine theta versus theta graph of this sine function? Well, it repeats after theta, right? Before that, it doesn't repeat. So the minimum is 2 theta. So if you see this portion of the graph, the same thing repeats here, right? So this is sine theta. This is the period. Okay. But if you see, if you take one of this and two of this from here to here, even that will repeat, right? The whole thing, two period, two, also if you take that also will repeat, but we don't consider that as our period. We consider the minimum, the smallest part of it to be our period from here to here. Okay, that is the sine graph. Cosine graph also similar. Okay, it looks the same, but sine graph started at 0, cosine graph starts at 1 and decreases, right? Cosine 0 is 1, cosine 30 will be root 3 by 2, this, sorry, half, then, sorry, it will be root 3 by 2, then this cosine 60 degree will be half, and then cosine 90 degree will be 0. So from 1, its value has reduced to 0. Then it will go to -1. Right? Then again it will go to 0, then it will go to 1, back to where it was. So this part of the graph repeats again and again. Okay. So that is the period. So the period is 2 pi. Okay. So what about tan? Tan's graph is a bit weird. Okay. So tan is y by x, but what they have done here is they have just calculated the value of y by x and they have plotted it on a graph. Okay. If you didn't want to calculate, it's a tedious process and you can't sit and do for every point, right? You can't take y by x and divide it each time, right? So we need a better method for tan. So that method is this. So we have our unit circle. We have this value of sine theta cos theta, right? This will be sine, this will be cos. Somehow we want to get some measurement which will directly give us tan. So how you get it is this. So I will show you that if you draw a tangent at this point, okay. Uh, Now, what can you say about this tangent? N dash, P dash. Is there anything that you can tell? Any triangles? These two triangles are similar, correct? OPN is similar to OP dash N dash, right? So you'll have this divided by this will be same as this divided by this, right? So you'll have y by x to be same as P dash N dash by O N dash. But what is this length O N dash? Nothing but length is 1, right? So this length is just 1. So just this height will give you the tan of an angle. Hence the name tangent, right? We get the length of this tangent. Okay. Tangent of an angle is this because this line is a tangent to this circle. So basically, how do you get the value of tan for an angle? You draw the angle and uh, draw a tangent, extend that, that will give you the y coordinate of tangent. Of course, x coordinate is nothing but this angle theta. But for negative values, you need to be careful. Okay. For obtuse angles, you need to be slightly careful. It won't still remain this because your line will go in this side. So you'll have to draw a tangent here, but just see what the tangent values are here. Are they positive? Are they negative? Based on that, you need to draw a graph. Okay. Okay. So that's about graphs. Of course, I highly recommend you try and plot sine theta versus theta on your own because that will give you a lot of understanding not only regarding the graph of sine but also regarding theta, the x coordinate, and you will learn how to convert degrees into radians very fast. It will come to your mind well. Basically, what you need to do is you need to take angles 0. You need to take a graph sheet first of all and mark points. You know the value of pi is 3.14. So at a distance 3.14, or you can take 1 unit as 2 centimeters so that you can extend your graph. So at least from minus pi to 2 pi, you should find the graph. You should plot the graph. Okay. And then you first you try and plot the x coordinates pi by 2, pi by 3, pi by 6, then 2 pi by 3, 5 pi by 6, etc. Okay, so you have to roughly calculate these values and see where it lies on the x-axis. Okay, once you get that, what you do is you extend your unit, your this line, and draw a unit circle here itself. Okay. Right, and then if you draw your unit circle here, what you could do is take lines. So for example, pi by 6 you draw. You can just extend this pi by 6 here up to here, and that will give you the value of sine pi by 6. Okay. Then suppose you want pi by 3. Okay. This height will give you sine pi by 3. So you just extend this here. That will give you sine pi by 3. Okay. And pi by 2 is this line. So you extend this, you will get sine pi by 2. Okay. So once you mark these points, all these points, you will see that you connect it to the smooth curve, you'll get a graph something like this. And we have got some very beautiful graphs by students who have drawn this very carefully. There are some observations which you can make, right? You will see that not only it is periodic, but also it is symmetric, right? So about this line, if you take this line, about this line, you will see that this side of the graph and this side of the graph is perfectly symmetric. So you can write down your observations, whatever are there regarding this graph, and then we can further discuss. You can discuss about that. Okay. So it's a very good exercise. I highly recommend this. Sine theta versus theta, even tan theta versus theta is the same thing. Instead of just extending this, now what you have to do is you have to draw a tangent and extend this value. Okay. Again, the tangent here, extend this value. That will give you tan of that particular angle. Okay. Okay. So tan in the second quadrant, will tan be positive or negative? What do you think? If you take tan in the first quadrant, it is just y coordinate by x coordinate, right? Y coordinate is positive, x coordinate is positive. Therefore, tan has to be positive. No doubt about it. If you go to the second quadrant, y coordinate divided by x coordinate, correct? Is the y coordinate positive? Y coordinate is positive. What about the x coordinate? X coordinate is negative, right? Because you're moving in the negative direction here, correct? So positive divided by negative. So the tan value is positive. So whatever value of tan you get here, you have to invert it. You have to invert it to get tan. Okay. And in the third quadrant, what about third quadrant? The y coordinate is negative. What about the x coordinate? That is also negative. So you'll have negative upon negative, which will give you positive. And in the fourth quadrant, you will have negative divided by positive. Okay, this is negative, this is positive. So negative by positive will give you negative. So tan will be negative. If we have to compare tan theta with tan of theta plus pi, if this angle is theta, how do we get theta plus pi? Theta plus pi, right? Pi is nothing but 180 degree. So from here, we have to go 180 degree, right? So it will be in the opposite direction of this ray, right? So effectively, I just need to extend this ray in the opposite direction, right? So theta plus pi is same as theta plus pi, or I could think of it as pi plus theta, right? So this angle is theta. Okay. And now if you look at these two triangles, what can you say about these two triangles? They're definitely congruent, aren't they? hypotenuse is the same, this angle is same, another angle is same, right? And so from AA is these two are congruent, right? So this by this will be equal to this by this, right? So tan of x will be same as tan of pi plus x. Okay, tan theta and tan of pi plus theta is exactly the same. Okay, so if you have to draw the tan of a value here, it won't be negative, it will be positive. But since instead of taking this and taking it in the positive direction, you can just extend this line because you know tan of pi plus theta is same as tan of theta. Correct? Okay. So now we are going to look at trigonometric ratios of some complementary angles. Okay. And we're going to do some other angles also later. So first, let's look at these angles. So if we have, okay, so we have in this sine theta is nothing but the y coordinate, right? So suppose we have to find sine of pi by 2 minus theta, 90 minus theta, right? So pi by 2 is 90 minus theta. Which angle is 90 minus theta here in this particular? This angle will be 90 minus theta, right? So what we will do is we will draw another triangle. We will draw another angle which makes 90 minus theta. Okay. So let me name this point P dash. Okay. And let me drop a perpendicular. This is N dash. So this angle is 90 minus theta. Okay. Let me name it. This angle is 90 minus theta. So what will, if you look at this triangle, what will this angle be? P dash angle P dash. This angle is 90 degree. This angle is 90 minus theta. So the remaining angle will be theta, correct? So even in this triangle, we have one angle theta, one angle 90 degree. So what will be this remaining angle? This has to be 90 minus theta, right? So definitely the angles are the same. What about the side? The length of the hypotenuse, they are the same, right? Both are unit radii, so both lengths are 1, correct? So we have triangle OPN is congruent to triangle. You have to take care of the order, okay? OPN, so N is the right angle. So in this case also N dash will be the right angle, okay? So that will come last. What about the first two? We had OP, this angle O to be theta, right? So, but we want this angle to be theta. So here we have to take P dash ON. Okay, so P dash ON, this angle will be 90 minus theta. Similarly, OPN, this angle will be 90 minus theta. You have to take corresponding sides, right? Corresponding vertices. So these two triangles are congruent. So what will be sine of 90 minus theta? Sine of pi by 2 minus theta will be this height, right? 90 minus theta, the corresponding height, which is P dash N dash, correct? And but P dash N dash is same as which length in this triangle? We have P dash N dash should be same as ON, right? Which is this length, right? So this is same as ON. And what is ON? ON is the x coordinate. So ON is cos theta. What about cos of pi by 2 minus theta? cos of pi by 2 minus theta. Cos will be the x coordinate of this ray, right? X coordinate is ON dash, right? And ON dash is same as PN, right? PN is nothing but the height here, isn't it? The height in the original triangle, and the height is sine theta. Okay. So we have sine of pi by 2 minus theta is cos theta, and cos of pi by 2 minus theta is sine, right? So these are very important. You should remember this. Okay. Sine of pi by 2 minus theta is cos theta, cos of pi by 2 minus theta is sine theta. Now using this, you can derive the expression for tan of pi by 2 minus theta. What will be tan of pi by 2 minus theta? It will be sine of pi by 2 minus theta by, sorry, sine of pi by 2 minus theta we saw is cos theta, right? And cos of pi by 2 minus theta we saw is sine theta. So you'll have cos theta upon sine theta, which is cot theta. Okay, so tan of pi by 2 minus theta is cot. Similarly, you can get all the other ratios, secant, cosecant, cot, all these ratios you can get. Okay, so that is the sine and cos of complementary angles. Pi by 2 minus theta are complementary. So suppose we want to find some pi by 2 plus theta or pi plus theta or pi minus theta, right? Instead of each time doing this triangle and comparing it with this triangle, what we could instead do is come up with a general formula. So come up with a general formula for cos of any A, any B. Okay, A plus B, A minus B. Similarly, sine of A plus B, a sine of A minus B. If we come up with a general formula, we will be able to apply that for both of this. Right? And any general question we have. So that is what we're going to do next. Before that, we need distance formula. So I'll just quickly, in case you don't know what is distance formula, I will quickly introduce distance formula to you. So suppose you have a line, okay, and its coordinates here are x1, y1, its coordinates here are x2, y2, okay, and you want to find the distance between x1, y1 and x2, y2. Okay, what do you do? Well, you can just divide this into a triangle, which is ABC, right? And the whole length for this x2, y2, this length is x2, this length is y2. Similarly, for x1, y1, this length is x1, this length is y1. Correct? So we need to find this length, AC square, which will be AB square plus BC square, right? Because this is a right angle. So we want the length AB. So distance square is equal to AB square plus BC square. What is AB, length AB? This whole length we saw is x2, right? And this length we saw is x1. So length AB will be x2 minus x1. So AB square will be x2 minus x1 the whole square. What about BC square? This whole height is y2. This height is y1. So the difference is y2 minus y1, right? So BC square will be y2 minus y1 the whole square. Okay. So if we want the distance between 2 points, it is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay. This is distance formula. So just in case you have not learned about distance formula, this is distance formula. Now we take our unit circle again. We're going to take some special angles. Okay, we're not just going to take any angle. We are going to take some special angles. Okay, suppose in general, this whole angle is alpha. Okay, and this angle here is some beta. Okay, so let me name x, o, y, a, this point is b. So angle XOA is alpha and angle XOB is beta. What will be angle AOB? This angle. This angle is alpha. This whole angle is beta. So we want this, which is the difference of the two angles. Right? So the big angle minus the small angle. So it will be just beta minus alpha. So now I'm going to take a third ray such that actually doesn't look acute. Let me try and make this acute. Yeah, now this looks better because I wanted this angle to be acute angle. Okay, so now I'm going to construct a third angle such that this angle should be same as this angle. Whatever angle here we have, that is the same angle here. I'm going to construct it such that that happens. Okay, C, point C. Okay, so angle XOC is beta minus alpha. I'm going to construct this. Okay, so we have this angle equal to this. Okay, now if I connect these two, and similarly connect these two, both these angles are the same, right? What are these two triangles? Can we say something about these two triangles? Do they look congruent? They look congruent, right? These two angles are the same. These two sides are exactly the same, right? And these two sides are also the same because all of them are radii of the circle, correct? So this length equal to this length, which is equal to this length, which is equal to this length. Okay, all of them are radii. So you will have triangle XOC is congruent to triangle AOB. Okay. This triangle is congruent to this triangle. Okay. That means this length is equal to this length, right? So we have XC, which is equal to A. Okay, I'll just write XC square is equal to AB square. You will see why. What will be the coordinate of this point? Coordinate of X. X coordinate is 1, Y coordinate is 0, right? So we will have 1, 0. What about this A? This angle is alpha, right? So what will be the X coordinate? The X coordinate is nothing but cos alpha, right? We have seen this. If you take any angle alpha, this X coordinate has to become cos alpha. The Y coordinate will be sine alpha, right? So this is cos alpha, comma sine alpha. Similarly, this point will be cos beta, comma sine beta. This angle is beta minus alpha. Similarly, this angle is beta minus alpha. This point here will be cos of beta minus alpha. And the y coordinate will be sine of beta minus alpha. Okay, because the angle it makes with the positive direction of the x-axis is beta minus alpha. So cos of that will be the x coordinate, sine of that will be the y coordinate. Okay. So we have the x, y coordinates of all the points. Okay. So what will be xc whole square? From our distance formula, we have d square. D is equal to root of this. So why didn't I take xc is equal to ab? Because we will have root of something is equal to root of something, right? So to avoid that root, I just took d square, which is x2 minus x1 whole square plus y2 minus y1 the whole square. So xc. So in this minus this the whole square. What will it be that? Cos of beta minus alpha minus 1 plus y2 minus y1, which is sine of beta minus alpha minus 0. So sine of beta minus alpha, the whole square. This is equal to AB square. What is AB square? Nothing but x2 minus x1 the whole square, which is cos alpha minus cos beta the whole square plus sine alpha minus sine beta. Okay. So let me just move this. So we have this whole square is equal to this whole square. Now we need to simplify. So please pause here and try simplifying this on your own and see what you come up. You should come up with some expression. Okay, so uh, sine of beta minus alpha, cos of beta minus alpha, um, this whole square, so sine of beta minus alpha whole square. So generally, when you have sine of a function, sine x whole square, instead of writing this bracket every time, we can also write it as sine square x. Okay, it means the same thing. Okay, instead of writing the bracket every time, we can write like this. Or if this is whole power 3, you can write it as sine cube. Mind you, this is not equal to sine of x squared. Okay, we are not taking the angle, squaring it and finding the sine. No, we are finding the sine of that particular angle, then we are squaring it. Okay, the squaring comes later. Okay, so sine square means sine of x whole square, not sine of x square. Please don't make this mistake. Okay. Okay. So now this I can write as a minus b whole square is a square, which is cos square beta minus alpha, plus b square, which is 1, minus 2 cos beta minus alpha, minus 2ab. And this will just be sine square beta minus alpha. Okay, what about the RHS? RHS will be a minus b whole square will be cos square alpha plus cos square beta minus 2 cos alpha cos beta plus again a minus b the whole square sine square alpha plus sine square beta minus 2 sine alpha sine beta. What is sine square x plus cos square x is equal to? I hope you learned in the previous classes. I think you have already learned. This will be equal to 1. Okay, sine square of an angle plus cos square of an angle is equal to 1. If you want the proof of it, quick proof. Uh, so So sine is this, right? The x. So should take x. Let me take theta p n o. Sine square is this square, correct? Cos square is this square. So this square plus this square will be equal to this square, right? And this square is nothing but the hypotenuse. OP is the hypotenuse of a unit circle, right? So how much is this square? OP square is just 1. Okay. So you have sine square plus cos square is equal to 1. Okay. So using that here, we have 1 cos square alpha, we have 1 sine square alpha, that will give us 1, right? And we have 1 sine square beta and a cos square beta, that will also give us 1. We also have a cos square beta minus alpha and a sine square beta minus alpha. That also will give us 1. So in the LHS, we have this will give us 1. So 1 plus 1 is 2 minus 2 cos of beta minus alpha is equal to cos square alpha plus sin square alpha will be 1. Cos square beta plus sin square beta will be 1. So we get 2 minus 2 cos alpha cos beta minus 2 sin alpha sin beta. Okay. Now 2 and 2 will get cancelled. We can take minus 2 out here common. So we'll get cos alpha cos beta plus sin alpha sin beta is equal to minus 2 cos of beta minus alpha. So this minus 2 will cancel away. You're left with cos of beta minus alpha is equal to cos alpha cos beta plus sin alpha sin beta. So this is a very important identity which we have just derived. Cos of beta minus alpha is cos A cos alpha cos beta plus sin alpha sin. This is our first identity. What about cos of beta plus alpha? Think about this. How can we derive cos of beta plus alpha? Well, instead of going through all this again, what you could just do is, instead of, we could write this, can we write this as same as cos of beta minus alpha? We can do this, right? And then let's substitute the, or if you're getting confused, let's write it as b plus a so that we're not using the same alpha. So we can write it as b minus a. Okay. So what is cos of one term minus other? Cos A cos B. So it will become cos B cos minus A plus sin A sin B. Right? So sin B sin minus A. Right. What is cos of minus A? Cos of minus A can be written as, we derived this, right? Cos of minus theta is same as cos theta. Sin of minus theta is minus sin theta. Right? So an example here would be, so if you want to take say sine of minus 30 degrees, it is minus sine 30 degrees. Okay. And sine 30 is how much? Half, right? So get the value minus half. What about cos of minus 30? Now, cos of minus 30 will be same as cos 30, which is root 3 by 2. So just wanted to give you that example. So we have cos of minus a will just remain cos a. So we'll get cos A cos B. Sine of minus A, we saw it minus sine. So this will become minus sine A times sine. So that is cos of A plus. Now think about, we have got both the cos just with this, just with simplifying this and what we have done before, we can get sine of A minus B, or sine of A plus B. Try to derive sine of A plus B, see what you get. Please try. Sine of A plus B. Well, we've seen here that given the cos of something, we can write sine of pi by 2 minus theta to get cos of that angle, right? So if we have cos of A plus B, we can write it as sine of pi by 2 minus that, or if we have sine of something, we can write as cos of pi by 2 minus that. Okay, so here in this case we have sine, so we can write this as cos of pi by 2 minus this particular angle, which is A plus B. Okay, now you need to group it slightly carefully. Okay, now if you directly apply this formula here, okay, if you directly apply cos A cos B plus sin A sin B, you won't get anything. You can try that. What you need to do is, you need to group it slightly differently. So what you could do is, you could write it as cos of pi by 2 minus A minus B. Okay, and you could group this as your first term and this as your second term. Okay, so cos of beta minus alpha we saw was cos alpha cos beta plus sin alpha sin beta. So it will be, this will be cos pi by 2 minus A cos B plus sin pi by 2 minus A sin. Right? What is cos of pi by 2 minus A? This is sin A and cos B. And sine of pi by 2 minus A is nothing but cos A and sin. So sine of A plus B, sine of A plus B is sin A cos B plus cos A sin B. Okay. Moving ahead to sine of A minus B. How can we write a sine of A minus B? We can write it as sine of A plus minus B, right? And we can write this as sine A using this formula. And write it as sine A cos minus B plus cos A sine minus B, which is sine A. Cos of minus B is same as cos B, right? We saw this just now. What about sine of minus B? Will be minus of sine B, right? So we get minus of cos A sine B. This is sine of A minus B. Okay, so that is your other idea. So we started with cos of B minus A, cos of A plus B, sine of A plus B, sine of A minus B. So we have 4 different formulas which you need to remember. You definitely need to remember these. Okay. Now what you could do is you could apply these to different values. So we have sine, cos, tan. First is minus theta. What is sine of minus theta? We just saw sine of minus theta will be minus sine theta. Cos of minus theta will be cos theta. And tan of minus theta will be this divided by this, right? Which is minus sine theta by cos theta, which is minus tan theta. Okay. Next, we go to pi by 2 minus theta. What was sine of pi by 2 minus theta? We found this to be cos theta. Cos of pi by 2 minus theta was sine theta. And tan of pi by 2 minus theta will be this divided by this. Sine of pi by 2 minus theta divided by cos of pi by 2 minus theta, which is cos theta by sine theta, which is cot. Next, if we have to see pi by 2 plus theta. What is sine of pi by 2 plus theta? Sine of a plus b. Sine of a plus b is sine. What is sine of a plus b? Sine a cos b plus cos a sine b. Correct? So you'll get sine a cos b plus cos a sine b. What is sine of pi by 2? Sine of pi by 2 will be this goes to 1. Cos pi by 2 goes to 0. So this whole thing will go to 0. 0 into sine theta will go to 0. So what are you left with? This will be cos theta. So this will just be cos theta. Okay. What about cos of pi by 2 plus theta? Cos of pi by 2 plus theta. Cos of a plus b. What's the formula? Cos a cos b minus sin a sin b. Okay. So cos pi by 2 cos theta minus sin pi by 2 sin. Okay. Again, cos pi by 2 is 0. So this term will go to 0. Sin pi by 2 is 1. So this will be minus sin theta. So this is minus sin theta. And this will, you will get minus cot theta. Okay. Similarly, homework for you will be completing this table. Pi by 2 minus theta, sorry, pi minus theta, pi plus theta, 3 pi by 2 minus theta, 3 pi by 2 plus theta. Okay, that's it. So if you complete this table, that is your homework. Okay, you'll be able to see some patterns there, okay, which you can further, which we will further explain.